Hello, this is Robert Waller, and I wanted to show you one slide out of a presentation, Cultural Property Risk Assessment, Matching Approach with Purpose, that I gave at the International Council of Museums Committee for Conservation in 2008. And the one slide I want to show you has to do with the problems in using a categorical scales like simple step scales for ranking risks. These problems were described in detail by Tony Cox in a recent article in Risk Analysis, and I refer you to that for the details. But here I simply want to compare the use of a normal rational scale with what's called a simple step scale. Now, a rational scale uses numbers like we've all used to, 1, 2, 3, 4, and so on, up through 10, 100, 1,000, and getting larger like that. Now, a simple step scale can be defined on top of this kind of scale so that it's like a logarithmic scale. The number 1 corresponds to numbers between 1 and 10. A step of 2 corresponds to the numbers between 10 and 100, and so on. Now, in this way, you can get to some fairly simple little numbers that you can add together to calculate a risk. But there are occasionally some difficulties with that. And to explain that, I want to introduce a few characters here. This is George, and we're going to see George a number of times. He's going from work on the left to his bank on the right, and he's carrying his day's earnings. On the route, he's going to meet a few unsavory characters. He's going to meet a flying thief sometimes he's going to meet a running thief, and sometimes he's going to meet a bicycle thief. And we're going to see how George does against each of these characters. Now, so just to go through it again, the idea is that George, he goes from home to the bank carrying his day's earnings, and that would describe a successful kind of project. He gets there and everything's okay. But it may happen that he runs into one of these characters, and then there's a theft event. Okay, in the case of the flying thief, we're looking at George doing this trip every day through a year. And we're going to say, well, when he meets the flying thief, that's going to happen 3 times through the year. Each time 5 coins will be taken, and the coins will have a value of 7. Let's call them denarii. George is kind of an old-fashioned guy, and he collects these denarii coins. So the flying thief gets 5 coins. Each coin has a coin value of 7. Using numbers the old-fashioned way, we could calculate 3 times 5 times 7. He's going to lose 105 denarii. On a simple step scale, 3, 5, and 7 would all correspond to a 1. So we'd score 1 plus 1 plus 1 equals 3. Now, let's see what happens when George meets the running thief. Oh, through the year, the running thief is going to rob George 2 times. Each time he's going to take 13 coins, and the coin value, each of those 13 coins, will be 15. Now, the old-fashioned way, we calculate 2 times 13 times 15 is equal to 390 denarii. Using a simple step scale, we've got the 2 times robbed corresponds to 1. The 13 coins and the 15 coin value corresponds to 2. So we have 1 plus 2 plus 2 equals 5. This would rank as a 5 risk there. Now, George is going to meet the bicycle thief. And how does he make out there? Oh, that guy's bad. Bicycle thief gets George 7 times through the year. He only takes 8 coins each time, but the coin value is 70. When we multiply 7 times 8 times 70, we get 3,920 denarii stolen from George. Boy, let's see how this works on the simple scales. Well, the 7 and 8 correspond to a 1, and the 70 corresponds to a 2. So we have 1 plus 1 plus 2 equals 4. Now, let's see how these two ways of calculating the risk work out. Here we see the running thief is going to get 390 denarii over the year from George. The bicycle thief is going to get over 10 times that much, almost 4,000 denarii. Now, the simple scales, however, show that the running thief we expect to be the bigger problem. He gets a rank of 5, much higher, well, a full step higher than the bicycle thief. Because this is a logarithmic scale, that suggests a full step suggests it's 10 times worse, when in fact we see that it's really the running thief is only 1/10. It's 10 times less significant than the bicycle thief. So we find that the step scales reverse the ranking from what it should be, but they also imply, well, not that the error isn't a matter of 10 or 20%. This implies that the running thief is 10 times more significant a risk, when it should be just 10 times less significant. So the simple step scale is wrong by a factor of about 100. That's fairly serious for just the way we structure our risk ranking. We don't like to see the structure of our risk assessment method create errors that significant. Okay, thanks for your attention.